Ever wondered what makes fireworks explode or how a simple matchstick lights a fire? It's all about chemical reactions. This invisible dance of atoms and molecules is happening all around us and even inside us. From the rusting of an old bike to the digestion of our food, chemical reactions are integral to our everyday life. Now, there are 5 major types of reactions that scientists have identified: synthesis, decomposition, single and double displacement, and combustion. And here's a fun fact for you. Do you know how many chemical reactions are happening in your body right now? Well, it's estimated that the average human body conducts over 100,000 chemical reactions every single second. That's quite a molecular ballet, isn't it? So let's dive into the fascinating world of chemical reactions and learn about each type in detail. Imagine 2 friends coming together to form a team. That's pretty much what happens in a synthesis reaction. In the grand dance of chemistry, synthesis reactions are the steps where 2 or more substances decide to tango together, forming a brand new compound. It's like a party where all the guests decide to join forces and create a supergroup. Now let's look at a classic example: the formation of water. You've got hydrogen and oxygen, 2 gases that are pretty impressive on their own. But when they come together in a synthesis reaction, they create something essential to life itself: water. It's like hydrogen and oxygen decided to hold hands and take a plunge into a whole new existence. They go from being separate entities to becoming H2O, a compound that covers about 71% of the Earth's surface. So next time you take a sip of water, remember, it's the product of a synthesis reaction, a beautiful chemical partnership. Synthesis reactions, bringing elements together since the dawn of time. Ever seen a building being demolished? That's a real-life metaphor for decomposition reactions. Just as a wrecking ball breaks a building down into rubble, decomposition reactions break down compounds into their constituent elements. They're kind of the rebellious teenagers of the chemical world, always breaking things apart. Think of them as the polar opposites of synthesis reactions. While synthesis reactions are all about creating something new, decomposition reactions are all about taking things back to their roots. It's a fascinating process, one that shows us how versatile and dynamic our universe can be. Let's take water, H2O, for instance. Through the process of electrolysis, we can break water down into its basic parts, hydrogen and oxygen. It's like reverse engineering at a microscopic level. And decomposition isn't just a fancy scientific term. It's a crucial process that happens all around us, in our bodies, in the environment, even in the food we eat. Decomposition reactions, because sometimes things need to break apart. In the world of chemical reactions, sometimes elements like to swap places. That's where displacement reactions come in. Picture a dance floor. In a single displacement reaction, it's as if one dancer, let's call him zinc, cuts in and takes the place of another, hydrogen, who is dancing with chloride. This leaves poor hydrogen out in the cold and zinc and chloride dancing together. In chemical terms, when zinc reacts with hydrochloric acid, it displaces hydrogen from the compound, creating zinc chloride and hydrogen gas. It's a simple swap, one element for another. But what if we have 2 couples on the dance floor? That's where the drama of a double displacement reaction comes in. Imagine we have 2 dancing couples, barium and chloride, sodium and sulfate. Suddenly, they decide to switch partners. Barium leaves chloride and pairs up with sulfate, while sodium swoops in to dance with chloride. This partner swapping is exactly what happens in a double displacement reaction. When barium chloride reacts with sodium sulfate, the elements swap partners, resulting in the formation of barium sulfate and sodium chloride. Now, don't you think these reactions could be the plot of a soap opera? It's all about the drama, the tension, the sudden switch of partners. But in the end, it's all about achieving a balance, finding the right partner to create the most stable compound. That's the beauty of chemistry. It's a dance of elements, each seeking its perfect match. Just like dancers, elements in a compound can be replaced either singly or doubly, leading to new compounds. These reactions are essential in many areas, from manufacturing to environmental science, even in our everyday lives. So the next time you see a chemical reaction, remember, it's not just science, it's also a dance. Displacement reactions, shaking things up in the world of chemistry. Last but not least, the fire starters of chemical reactions, combustion reactions. These dynamic reactions are the ones that really bring the heat, quite literally. They occur when a substance interacts with oxygen, leading to the production of light and heat. This is the stuff of bonfires, candle flames, and even the explosion of fireworks on a starlit night. Think about the last time you sat around a campfire roasting marshmallows over the dancing flames. That's a combustion reaction in action. The wood or fuel reacting with the oxygen in the air to produce carbon dioxide, water, and most importantly, heat and light. It's a process that's been keeping us humans warm and cooking our food for centuries. Now let's take a leap from a cozy campfire to a grand fireworks display. Those brilliant colors illuminating the night sky, they're the result of combustion reactions too. A firework is essentially a carefully crafted package of chemicals, including a fuel and an oxidizer. When ignited, the fuel reacts with the oxidizer, releasing heat, light, and gas. The gas expands rapidly, causing the explosion that sends the fireworks sky high, while the heat and light create the dazzling display we all enjoy. But combustion reactions aren't just about bonfires and fireworks. They're integral to many aspects of our daily lives. Every time you start your car, a series of combustion reactions takes place in the engine, converting gasoline and oxygen into carbon dioxide, water, and energy. The energy that powers your vehicle. And it's not just cars. Many power plants generate electricity through the combustion of coal or natural gas. Even the food we eat provides fuel for combustion reactions in our bodies, releasing the energy we need to live, move, and think. So the next time you're gazing at a starry night, remember the combustion reactions, making it all possible. From cozy campfires to dazzling firework displays, from powering cars to lighting up cities, these reactions are truly lighting up our world. Combustion reactions, lighting up our world one reaction at a time. So there you have it. The 5 major types of chemical reactions. We've uncovered the magic of synthesis reactions, where 2 or more simple substances combine to form a more complex one. Then, we've seen the opposite in decomposition reactions, where a single compound breaks down into 2 or more simpler substances. We've also delved into the fascinating world of single and double displacement reactions, where elements in compounds swap seats like in a game of musical chairs. And lastly, we've ignited our understanding of combustion reactions, where substances combine with oxygen to produce heat and light. All these reactions are not just confined to lab experiments, oh no. They're happening all around us, from the rusting of iron to the baking of a cake to the burning of a candle. These reactions shape our world, making chemistry not only a subject to learn, but a reality to live. Isn't chemistry amazing? Keep exploring and remember, every reaction counts.